So next topic is about the routing. What is the routing? What we are discussing, first of all, what is the routing? Just a very basic understanding. I think this is the concept we have explained multiple times in the previous lectures. Routing is happening at the layer 3 network, layer 3 device, at the layer 3, sorry, layer 3, at the layer 3. So you can see, just give an example, just think about it, a different direction. So when you are going onto the motorway, you might see a different sign actually, and it's defining in which path you are going. So for example, somebody is going to, if you are coming from one side and you want to go to into the Milton Park, for example, or you want to go to the power station, you take the roundabout and you follow the particular exit, so you can take you can go to your destination. So router job is, or the routing mean direction, in which direction you are going, in which direction you need to leave. So here you can see one example. One guy is going to office, okay, and he is finally reaching to his, and here you can see he has multiple direction, which way is office, which way is airport, which way is home, okay. So he's going from home, okay, so he will take the direction according to his destination. So because today his destination is office, not airport, not home, or not anywhere else, he has 3 directions to follow, right? And he is following those directions according to his destination. We can also know that day to day letters are delivered at the specific address. Each, for example, house has a number, right? Street may be the same, but house has a different number. Just we discuss about IP addresses, subnetting, networks. These are just a data example. Similarly, so what is the routing? That's the previous example we have given you. They are related to day-to-day, our example, where we, I just giving you the example, what is the routing? What is the network routing, right? So how the router is doing. As you can see, router is connecting to each of its network, is in a different network. This is 192.0.24, this is 2.24, this is 3.24, 1.0.24. So these are the different network. These are different subnet. Or you think about it, these are different street, right? So if somebody say, here I want to go to 2.100, so in which direction he should go? Top, right, or bottom? It comes to the router. Router will decide, or he will direct in which direction he should be going. He discovered this path, 192.168.2.0 on this, from this side, from the top side. So once it comes to the router will consult. It has a big database. It has a routing table. It consults the routing table, and it will direct the guy to its direction. That's it. So look the destination IP or destination network, not even the IP. Keep in mind, router do not care about the IP. They care about the street. They care about the network. They do not know the end host. Switches knows the end host. Router do not know the end host address. They just care about street, networks, which network they need to go. Okay. So if somebody wants to go to a network called 192.168.1. Do we have this network, by the way, guys? It's coming here. Okay? How about if somebody come to 192.168.5.240? If it's not there, discard it. Clear? So router will not do any kind of broadcast. Like switch. If switch doesn't know, it will forward to all the ports. Router do not do that. Router by default stop the broadcast. So what is a router? A router need to know a remote network, neighboring router, all the possible route to the remote network, the absolute pass route to the remote network, maintain and verify. So most importantly, it need to know the remote network, for example, from here to here, number one. Then neighbor routers, A, B, C, D. You need to know what neighbor he is connected to. Maybe he also need to know how many possible paths he has to reach to the network. And maybe another thing, what is the best one? If it has multiple paths, which one is the best one? And then most importantly, once he discovered that, he need to maintain and verify the routing table. After a certain period of time, it will start to discover this guy is existing, that guy is existing, something like that. So that's just a simple example of routing. We have a one network of 192.168.5. Another network is 10.0.5. Router one side, one interface is connecting to 192 network. Another interface connected to 10 network. And this is actually maintained inside the routing table. I want to communicate 10.0.5. Go through the router consult the routing table. You say, oh, you want to reach to this guy, please exit from this door. Okay? I'm happy if you leave this way, you should be able to reach this guy. Okay? Another example I just given you, router can, we have, when they discover the route, they have multiple paths. So when you do a navigation, you want to reach to Heathrow, as you can see from our destination, if you want to go to Heathrow on the Google Map will show you multiple paths. So maybe the optimal path is going through this way. However, you can see this is the one. This is a multiple path available as well. Okay? So let me see if I can click. If I double click that, you will see this multiple path is existing. So you see, I want to go from this postcode to the Heathrow Airport Terminal 1 to 3. I have multiple paths. So I have one path is going this way, and I have this one is also available as well. Okay? So you can see this is 1 hour 20 minutes. This is one path, and this is another path. Okay? So you can take multiple paths. So this is just explained here as well, that if you host A want to reach to host B, it has one path here, and one path maybe going from different router and finally reaching that, or maybe third path here, or maybe fourth path here. So one router can reach to multiple routes to the destination by multiple paths. Depending upon the routing protocols you're using later on, it depends, you are using one path, or you're using second path, or second path is just for backup. How many paths it can have, that information comes later on.